Hey, Professor Caps, it's Michael James here with the final Week 8 Interactive Advanced Concept. We're going to be making a polymer chain here. I want to show you my raw ingredients. So I picked up some sand from just one of the playgrounds near my apartment. I'm hoping that this works. I tried to go on a day where it was dry. And then I've got some cornstarch, and I've got some dish soap. So I'm going to go ahead and make the initial mixture of soap and cornstarch. What I'm going to do is I'm going to put 3 to 4 tablespoons of cornstarch in this bowl. Then I'm going to add soap, and I will come back when my solution is complete. I'm going to show you my solution now. It kind of looks like, I don't know how well you can see it. I don't want it to. It looks like almost like a ice cream, I guess you could say. I'm going to add a little bit more soap into this, and then I'm going to go ahead and slowly start to add sand. Alright, got my sand here. I'm going to go ahead and put it in. I guess I'll use a measuring cup just to make it accurate. I got a 1/3 cup here. And I'm going to go ahead and add another. Hope I got enough sand. Alright, I'm going to put the last of my sand in there. It appears very doughy. It's moldable. I think I need more sand, but it's see it's getting stuck to my fingers, but I got no sand coming off. It's almost like a paste, I guess you could say. I'm going to pause the video and I will come back once my hands are clean and explain what we got going on here. But there's my kinetic sand. So I let my solution sit while I went and cleaned up a little bit. It's almost rock hard now. Well, not really. If you mix it, it's still got the consistency that it originally had. But if you notice, it'll kind of mold to gravity. I guess we could call gravity a pressure here, and watching the solution kind of move downwards. I don't know how well you can see it, but it's slowly approaching the edge of the bowl. Pretty simple to clean up. I just washed my hands, and I guess the water and the soap kind of dissolved everything. All right, so I'll go and explain what just happened. Let's see. All right, so kinetic sand can be molded like clay, but it also feels silky. Now, I didn't quite feel the silky feel. My hands afterwards felt pretty soft, and they still do right now. But in this experiment, the sand has been coated with silicone oil. Silicone is deemed a group of materials that contain the elements oxygen and silicon. Silicones are polymers, which means that they're made up of long chains of repeated units, and they're almost very similar to the carbon backbones that we see throughout the world today. Silicone oils are unique in that they can be liquids that flow freely, kind of like what we saw when I held the bowl up with gravity, or semi-solids that flow freely when pressure is absent. So under stress, they behave like rubbery solids. This principle is called viscoelasticity. A substance's degree of viscoelasticity depends on the length of the polymer chain in the oil. So in the kinetic sand, the polymer chains within the silicone oil make the sand particles stick together. This is why they are able to be formed or molded like clay. However, over time, the ball will flatten. Viscosity is increased under pressure in kinetic sand. All right, take care. It was a great semester.